Okay, we'll go ahead and get started, although there may be some people still arriving in the next moment or so. They won't miss too much. We'll be kind of in a general overview probably through that point. So I'll just go ahead and get started. Just to introduce myself, my name is David Nolan. I'm the Senior Application Engineer for SmartSights, and I'll be the presenter today. And we'll be going over the topic of alarm management, which in a general perspective is basically just understanding the relevance to and impact of alarms on operations with the goal of improving efficiency, safety, and minimizing downtime. The flow of today's presentation will basically be an overview on some of the concepts of alarm management, why is it important, why do we need it, and how SmartSights software is involved or can be involved in an alarm management implementation. And of course, we'll take a few minutes at the end of the presentation to handle any questions coming in from the audience. So to begin, what is alarm management? I think before we describe the management piece, we have to talk about what the alarm piece is with respect to industrial control systems specifically. So ISA 18.2 standard defines an alarm basically as an audible or visible means of indicating to an operator that an abnormal condition is happening, and that it requires a response from them to resolve it, right? So there are the concepts of abnormal and expected conditions, the concept of whether action is required or not. And you basically, you're getting into semantics, of course, but it's important to understand these things, that an alarm really is only the condition where something is abnormal and actually requires a response from the operator. So what is ISA 18.2? It's a standardized framework. It's something that's understood and accepted by OSHA and the insurance industry. And it revolves around a 7-step sort of continuous process that aims to address common issues with industrial alarm systems. For example, information floods, right? There are so many conditions happening at the same time that the operator doesn't have a clear picture of what's happening or what they can do to resolve it. Poorly defined conditions, right? Alarms, this contributes to floods, obviously, but if there's a condition that really isn't abnormal, that occurs all the time, that's throwing an alarm, right? That can lead to the information flood. And together, sometimes these things can get so overwhelming or disruptive to the process that parts of the alarm system or the entire alarm system gets suppressed by the control room or by operators, and then they're basically in the dark because they can't see the real alarms through the flood of all of the false alarms. And so the goal of the ISA standard is sort of to prevent these things from happening and continuously monitor and improve the system so it's optimized to actually achieve its goal of safety and efficiency. So it happens basically by identifying the philosophy of alarms, right? Why do we need an alarm in this industrial automated system? And it's identifying conditions, right, to trigger the alarm, rationalizing how it happens, how it's enunciated. And there's a detailed process basically of identifying conditions and implementing a system that actually alarms on the conditions, right? So once this system is implemented, it's operated, right? We actually run the system and see how it works. We continuously monitor and assess it, right? We look at, if there are any kind of problems like these happening in the system, we basically monitor, we assess what those problems are, we discuss how we're going to change, and we basically re-implement the alarm system. We go back to operating and maintaining it, assessing it, changing it, and so forth. It's a continuous process to drive optimization and improvement. So why do we need to do all of this, right? How did alarm systems get so out of control? Had to do with the progression of technology in the past several decades. So you can see here back in this ancient control room from sometime in the 1970s or before, alarms were hardwired. They were hardware based, right? They took up space. You really couldn't have an unlimited number of them. So there had to be careful planning and management, right, around rationalizing the system, because there was just too much resource cost to be able to have a bloated and effective system. It didn't make any sense. There was no real way to arrive at a bloated system with the technological limitations at the time. So once we had digital, electronic HMI, SCADA, alarms became more or less defined in software. So they're very easy to implement, and you can have 10,000 different alarm conditions set up with way less effort than you had before this point. And so management now takes a back seat, right? Alarms are not always rational. There's too many conditions, the response is unclear. And so the system effectively can actually start reducing safety and efficiency again, because operators are distracted, they're constantly checking conditions, or maybe they suppress the system and now they're in the dark to any sort of dangerous things that could be happening, either dangerous for their safety or dangerous for the process. So these are a couple of extreme examples in history, but basically, poorly rationalized or poorly managed alarm systems have led to some catastrophic incidents in industrial operations. And one of those incidents is the Piper Alpha oil platform in the UK back in the 1980s. There was a sudden massive gas leak on this rig, and the control room operator actually received the alarm, and he basically initiated sort of a global plant shutdown switch that was to stop all gas flow anywhere in the entire rig, except that's not actually what the switch that he flipped did. Not all gas flow was stopped. The rig exploded. We had 167 deaths, including 2 rescuers, and billions of dollars in damage. All as the result of partly at least, of a poorly implemented alarm system, right? One other example is the Deepwater Horizon, which is a little more recent, where it was a similar situation where there was an undetected surge of gas, but nobody actually even knew that this was happening because the entire alarm system had been in inhibited mode for over a year. And so we all probably remember watching this on the news. There was a massive explosion. There were, I think, around a dozen or so deaths, injuries, large-scale environmental contamination. This is something that were the alarm system operating as intended, this entire incident may have been able to be avoided. So obviously, again, these are really extreme examples, but it just shows why good alarm management is important. So now let's transition over just to kind of talking about how SmartSights software is involved in an effective alarm management implementation. So think back to that 7-step process, right, in the ISA framework where we're implementing the alarm system. SmartSights Win 911 product is part of the alarm implementation, right? Because remote notifications are essentially an extension of the alarm system, right? So they allow alarms to be sort of routed and targeted with scheduling and escalation to make sure they get delivered to the right people at the right time through various methods. So in this way, remote notification software itself is part of the effective implementation of the system. Right? What conditions do we want to trigger remote notifications on? Who do they get delivered to? What method, so on and so forth. Now, we also get involved in the monitoring and assessment phase, or can be involved in that phase, right? Because we're monitoring the alarm system, we're capturing key metrics about it to help people understand it. Right? So think about the HMI alarm screen right on your in-plant HMI. It tells you what alarms are happening. Win 911's control center also allows you to see live alarms, acknowledge them, but it also presents you with analytical information to identify bad actors, right? Chattering alarms, alarms that are oscillating above and below their threshold, stale alarms, alarms that have been hanging around for a long time. This tool allows you to assess that kind of information in real time without the HMI, so you can go in and address problems that could be related to the configuration, right, of the alarm, for example, if it's a chattering alarm. And these widgets you see on these dashboards here are actually all tied to the ISA KPIs. So there's 12 ISA KPIs that are used to assess the health of the alarm system. And at a high level, they basically just have to do with things like, are there bad actors or nuisance alarms? Are there periods of very, very high alarm activity? Are there chattering alarms, stale alarms, and so on and so forth? So these widgets that you see in these dashboards are all based on these ISA framework concepts. Now, we also have the ability to generate longer-term reports on the notification system in Win 911, right? So we're looking not at the entire in-plant alarm system, but at the remote notification piece of it to assess problems that are occurring in that aspect of the implementation. So bad actors in the notification system, are we overloading certain contacts? Are they getting flooded with remote notifications? How much activity is occurring in our process network as we're sending out these notifications. And as a result of the information you see in these notification system reports, the idea is to rationalize the policies that are configured in Win 911, right? Check over the call out list timing, the workflow logic, the schedules, are the right people receiving the alarms at the right time? These kinds of reports allow you to identify problems, right, in the Win 911 configuration, if there are any, so you can go and address them. And then of course, this is sort of like a mini 18.2 cycle, right, related to the notification system itself. You operate, reassess, monitor the reports, identify problems, and continuously improve the system. So this is sort of one loop of monitoring and assessment that's happening just at the notification system level. Now we also have reporting solution that assesses the full scope IS 18.2 across the entire SCADA DCS, right? So this would be the factory talk, the Aviva system platform, the iFix, the system sitting beneath the Win 911 implementation. So again, we have the 12 ISA KPIs with red, yellow, green light indication of basically where you fall within the ISA standards. For example, the ISA believes that for a facility, 150 alarms per day, right, is an acceptable amount. And of course, you can change these thresholds as well, but these are basically red light, green light evaluations of your system against the ISA standards. The idea here is the same thing we just mentioned with notifications, where we basically run these reports. We get a high-level dashboard, we do drill down analysis, we can filter the information for certain operator positions, but the goal is to identify problems, go and reassess and readdress the alarm logic, go back to the operation phase, monitor and assess, and continuously use this loop to monitor and improve your system. These are some examples of the drill down reports you see behind this dashboard. So for example, if we're looking at top 10 contribution, we've got a Pareto analysis of the factors that contributed to that. So now we'll transition over to some hands-on here, and I'll actually kind of explain how some of these things work in practice with SmartSights software. So what you're seeing now is sort of a split view of a factory talk view SE alarm system, but this could be any HMI SCADA DCS system, and Win 911's control center, which is monitoring this system in real time. So for example, in my little simulated factory here, I can drop the level of one of my tanks, right? And Win 911 will react to that when it's happening. There we see tank 2. We can acknowledge view alarms here. We can acknowledge them back into the SCADA system. And this tool we can kind of think of as sort of just the control room, right, view of the alarm system in that factory talk implementation right through Win 911. So we can see these live alarms here. We can also see dashboards, right, that are sort of summarizing this activity and highlighting, where potential problems could be in real time, right? So I can see metrics like the number of alarms I've had in the last day. Again, that's your ISA total alarm metric. We can see our stale standing alarms, our active and unactive alarms, right? These are kind of the most critical problems we're needing to be responding to at the moment. And we can see things like our bad actors. We can see things like the percentage of time in which we've been in a flood, the number of alarm floods we've had in the past day. This is something where, for example, we would see these metrics here, and we could then drill down and look into, for example, what's causing this chattering. I can go into my history view here, and I can see, for example, if I look at the past few minutes here, I do have a chattering alarm that's happening on my tank 1, for example. So this is something I would probably go back and reassess either my policy or my implementation of factory talk to determine why is this, this chattering alarm happening. So the idea with all of these analytics we provide is basically to give you the high level information that tells you whether or not there's a problem, and then allow you to drill down and see what the problem is so you can fix it. Moving up sort of the layers of analysis that we do here, we have our real-time analysis in the Win 911 Control Center. We also have historical analysis of the notification system through Excel Reporter. So for example, if we take a look at some of these alarm reports in my example system here, I can look at, as that Win 911 system is operating and notifying people, what are the top actors over time, right? This is the same information that we're seeing from that control center, but it's designed for like a larger scope, longer term view. I can look at it over the course of days or weeks or months. I can generate this report automatically on a schedule, send it to people like plant management. I can look at different views of the notification system, right? I can look at an alarm-based view, what notifications are going out. I can look at a people-based view, right? Who are these notifications going to? Why are we getting so many? Why are we getting 1,000 notifications a day, right? Again, this is a simulated system, but this is designed, this view, for example, to highlight, right, if a particular person is being flooded, because when we're in the plant and alarms are going off on the HMI screen or enunciated by a siren, everyone's hearing them, but when it comes to remote notifications, right, everyone's sort of getting their own individualized feed of the alarms. And so these types of reports help you understand how that's affecting basically both your alarm system, the people receiving the alarms, as well as the different areas of the alarm system, for example, labels, right? I can look at the different types of alarms that are being sent through the notification system. Right? I've got a lot of activity happening in quality and safety. I've had a lot of activity happening in batch production events. And I've also had some concerning issues where I've lost communication, right, with my control systems. This gives us a perspective of the types of problems we're monitoring with remote notifications, how many of each of those are happening relative to each other. So this is sort of the analysis at the notification system level of any problems we might have, so we can go and address them. And we can also analyze data at the alarm system level itself, right? So now we're thinking about analyzing not just the subset of alarms going out by remote notification, but the entirety of the, like say, the factory talk alarm and event implementation. And that happens with these ISA 18.2 alarm reports. Right? In this report, again, we saw this in the slides, but it's going over the 12 ISA KPIs. So these have to do with the concepts that are fairly obvious, right? Average alarm rate per day, per hour, per 10-minute period. They also have to do with activity thresholds, right? So the amount of time you had more than 30 alarms per hour, which was basically all the time for this system. The amount of times you had more than 10 alarms in a 10-minute period. So it's giving you this idea of, what this actually looks like to the operator, right? If an operator is receiving 10 alarms in 10 minutes, they're really not doing anything with their life at that point besides responding to alarms. And so the process more or less comes to a halt. Flood percentage tells you the amount of percentage of time you were in a flood, right? Which is when we have more than 10 alarms in 10 minutes, we sort of are in a flood period, and the flood lasts until we go below 5 alarms in 5 minutes. So this is telling you when those high activity periods of time are in your process. And then there's also the concept of the top 10 distribution. This is basically telling you how lopsided your system is, right? If you're running an oil rig and you have 5,000 different alarm conditions, and the top 10 are making up 40% of the entire system, well, by definition, they're almost probably not logical alarms, right? Chattering fleeting, again, tells us alarms that are oscillating above and below an activation threshold very quickly. Stale alarms are alarms that have lasted longer than 12 hours. And then we have the average in and out of the flood to sort of give us a perspective of what the normal times in our process look like versus the abnormal times. And each one of these metrics has a detailed sub-report, right, that sort of speaks to the data behind it. So we won't go over every single one of these, but just to take an example of one, right? If you look at the top 10 contribution and we think, why is that happening? Why do I have such a lopsided distribution? What's causing it? We actually generate a sub-report that tells you why, right? It tells you that in this system, for example, right, the singularly top alarm, right, happened over 200 times in a day, right? We got another alarm that happened 120 times. So these are your bad actors. These are your nuisance alarms. The more lopsided this curve is, right, the more you have the worst actors, right, sitting at the top. And we also have a lot of general, housekeeping information, I guess, if you will, that happens in this report. Like, for example, we look at the concept of alarm acknowledgement time. Right, and we look at the average time it takes to acknowledge alarms, right? We have alarms that are taking hours for people to even acknowledge them happening, right? So that's something that we're looking at, not only the condition of the alarm itself, but what's happening with the operations, with the operators. Why is it this condition specifically, right? They're taking so long to acknowledge, and so this is something we would investigate more as a process and procedural kind of thing. We have the same thing with activation, right? This is the amount of time the alarm spends in the active state. We can keep track of alarms that have been suppressed. And again, this would be something we would go back to operators and process engineers and sort of ask them, well, why is this being suppressed? Why is it not useful? Is it distracting? What caused the suppression, right? Which in itself is sort of an abnormal behavior. So this report basically in total just helps us understand like what the operators are are seeing right behind some of these metrics. We can also filter these based on operator position. So we're looking at the entire plant, in this case, my simulated Franklin, Massachusetts plant. But what if I wanted to look at the view from a particular production line or process area, right? We can also do that. We can apply filters on here that filter out the areas of the system that are included in these metrics, so we can see the view from the fermentation area of the plant. And in this case, right, life doesn't really look so bad for this person as it does across the general plant or maybe some of these different positions. So this also allows us to target right particular production lines, areas, operator positions, and sort of perform the ISA rationalization loop from that person's specific perspective. Now, the end goal, right, of doing all this, right, is to make improvements and be able to tell, right, that you are making an improvement over time. And so we have built that layer into the solution. So as these reports are running automatically, these scores and the top 10 alarms are also being trended historically, right? So we can see how they're changing over time. So we have one more level of analysis at the very top here, which is how is the entire system improving over time, right? So this report here is actually looking at the history of these scores and seeing whether or not we're improving over time. So for example, at the plant level, right, this is what happened during the month of October, right? So we can see here we had days where we spiked. We can see where we had days where we got lower. This is something where were we to go back and re-rationalize this, right? Say on day 30, we go back and implement changes into the alarm system, we'd then be able to track this in the next 30-day period of time and see, okay, maybe now our total is actually going down. And again, we can assess these trends for different positions as well. So we can look at this, for example, for the fermentation position, and there were days in that position where we had no alarms at all, for example. So I think allows us to get that perspective of even if the whole plant is moving one way, it may be due to specific factors within the data set. I wanted to sort of cap it off here and take a few minutes to answer any questions that are coming in from the audience. But I hope today's presentation was helpful to all of you attending and understanding, what are alarms, what is alarm management, why do we need it, and what are the areas in which SmartSights can sort of help you implement alarm management as a way to improving efficiency, improving safety, and improving the operation of your industrial process.